Annuities. Emilio is planning to travel around Australia for 5 months. He invests $15,000 in an annuity that earns interest at the rate of 6% per annum, providing him with a monthly income of $3,040 per month for 5 months. Model this annuity using a recurrence relation of the form V0 equals the principal, Vn add 1 equals RVn subtract D, where D is the common difference, where Vn is the value of the annuity after n number of payments. So first we have to work out the rate. We need to work out the rate per month. So we know that it's 6% per annum, and there are 12 months in a year, so therefore 6 divided by 12 equals 0.5, and it's as a percentage. Now we use that value to get the common ratio. So the common ratio equals 1 add R over 100 equals 1 add 0.5 over 100, and that equals 1.005. So V0 equals 15,000, Vn add 1 equals 1.005 Vn subtract 3,040. So now we know the recurrence relation. So now we can use our calculator to determine recursively the value of the annuity after Emilio has received 3 payments from the annuity. So using our class pad, as you can see, we put in our values and we go to our table. You'll see after 3 payments we have $6,060.45. Is the annuity fully paid out after 5 monthly payments have been made? So let's have a look. We go down to 5 and we see that it's $26 and to 2 decimal places 1 cent. So the answer is no. So if not, how much will the last payment have to be to ensure that the annuity terminates after 5 months? In this case, we have to add it on to the common difference, and therefore it ends up being $3,066.01, and that's the last payment. So now we have to fill in the table, and to do that we have to remember one thing, the interest rate per payment, which is 0.5% per month. So to work that out, we can go to the main screen, and what we do is we have the balance of 15,000, and we can multiply that by 0.5 divided by 100. Go execute, and we get $75. Now to find the principal of reduction, we go $3,040, subtract 75, and then to find the new balance, we go the balance from the previous payment, subtract the previous principal reduction, and then we continue with the process. So to find the interest earned, we can just change the 15,000 on the class pad to the new balance of $12,035. Go execute. We get $60.18 to 2 decimal places, and we just keep going with the process. Now, because the balance now is $3,050.76, the next balance after that in payment number 5 is 0. So the principal reduction has to be the same amount as the balance in payment 4. So therefore $3,050.76. Now what we have to do is go backwards. So we find the interest for that balance. Go execute. $15.25. And now we add those two up. So we're adding the interest earned, and we're adding the principal reduction. And we should get $3,066. There we go. Now what we can do is add up the totals. And a good way to check is to make sure that the payment received, subtract the interest earned, is equivalent to the total of the principal reductions. Now, if you like, you can compare with the class pad. So if we go back to sequence, put in the recurrence relation, go to table, and go to the fourth payment here. You'll notice there's a slight difference between the value you see on the class pad and the value you see here. The reason being is due to rounding as you go. So this is one thing you have to watch out for. Annuities on the class pad using the financial solver. Here N is the total number of payments, I percentage is the annual interest rate, PV is the present value of the investment, so the amount that you give to the bank, so enter as a negative number. So just remember, any money or value that you give to somebody else, it's always going to be a negative value. Every time money goes to you, it is positive. PMT is the amount paid at each payment, amount that you receive from the bank each month, so enter as a positive number. FV is the future value of the loan or investment, so enter a 0 if at the end of the annuity, or positive for what the bank pays you back. PY is the number of payments per year. CY is the number of times in interest is compounded per year. It is almost always the same as PY. So in this example, Jane purchases a $50,000 annuity with interest at 6% per annum compounding monthly. If she wishes to receive a monthly payment for 10 years, how much will she receive each month? What we have to do, using the financial solver, is find the number of payments. Now, that's where we see this row here, N. The reason why it's 120 is because there are 12 months in a year, and this annuity is going for 10 years. So therefore, 12 multiplied by 10 is 120. Now we have our interest rate, which is 6%. Our PV is 50,000, but Jane is purchasing that 50,000, so that money is leaving her, so therefore it's negative. PMT is what we're trying to find. Our FV is 0. PY and CY, because there are monthly payments, that will be 12, because there are 12 months in a year. As soon as we press PMT, we receive our solution. So Jane's monthly payment will be $555.10. Peter purchases an annuity for $100,000 with interest of 7.5% per annum compounding monthly. If he receives payments of $800 per month, how long will the annuity last? So now we don't know what N is. Now we just have to substitute what we know. So we know that the interest is 7.5, PV is $100,000, but Peter is purchasing this value, so therefore it's negative. PMT is 800 and it's positive because Peter is receiving these payments per month. Our FV or future value is 0 because we want to know when it is going to be 0. Our PY and CY is 12 because there are 12 months in a year. And when we hit N, we get 243.93. And what we can do is round it up to the nearest whole number, so therefore Peter's annuity will last 244 months.